You know, the world around us is basically telling a story, and it's an absolutely epic one. It's a tale that's been unfolding for 4.6 times billion years. But how do you even begin to read a book that old? Well, the clues are literally hidden in plain sight, in the rocks, the rivers, everything that shapes our planet. And in this explainer, we're going to find the key that unlocks that whole story. Okay, so let's start with a puzzle. One that seems, well, pretty much impossible. Think about a tiny little stream. You know, one you might see trickling through a local park. Got it? Now, picture the Grand Canyon. I mean, this massive, incredible chasm carved deep into the earth. How on earth could one possibly lead to the other? The scale just feels wrong, right? It just doesn't add up.
But here's the thing. When you really break it down, the puzzle gets way simpler. Because the process for that little stream and the massive canyon, it's exactly the same thing. Water erosion. That small stream slowly wears away its banks, creating a little stream bed. And the Colorado River, it did the exact same thing, just, on a scale that's hard to even wrap your head around, and over an incredible amount of time. So the real difference isn't how it happened, it's how long it took.
And that right there, that gets us to the absolute heart of the issue. See, for most of human history, our whole understanding of time was the biggest roadblock. If you want to explain something like the Grand Canyon happening because of slow, steady erosion, you need a ton of time, a lot of it. And for centuries, well, that's the one thing people thought the Earth just didn't have.
So, up until the late 1700s, almost everyone believed the Earth was only a few thousand years old. That was it. And in that tiny time frame, there's just no way a river could carve a massive canyon. It's impossible. So how did they explain these huge mountains and canyons? They had to be created by sudden, massive, catastrophic events? The idea of slow, gradual change, it wasn't even on the table.
But then, a Scottish farmer came along with this totally radical idea, and it would completely change how we see our planet and its history. This is where we get to unlock the incredible concept of deep time.
So let me introduce you to James Hutton. Now, this guy wasn't some scientist locked away in a lab. He was a naturalist, and he was a farmer. And every single day, he'd walk his land in Scotland, and he would just observe. He'd see the soil washing from his fields down into the streams, and he watched those streams slowly carving away at the land. He was literally watching geology happen in real time, just at a total snail's pace.
And all this observation led him to this incredible, revolutionary thought. He thought, wait a minute, what if these small, everyday things I'm seeing on my farm, erosion, soil getting moved around, what if those are the exact same processes that, if you just give them enough time, could build up entire mountains and carve out massive canyons? It sounds simple, right? But the implication was absolutely profound.
So, okay, if Hutton was right about this, if these tiny, slow changes could create these gigantic features, the logical next question is kind of obvious. Just how much time are we talking about here? It clearly couldn't be just a few thousand years. No way. It had to be something just vastly, almost incomprehensibly long.
And today, modern science has given us the answer. 4.6 billion years. That's 4,600,000,000 years. It's a truly mind-boggling number. And that's the amount of time that Hutton's idea of deep time completely unlocked for us. And with that much time on the clock, suddenly the slow, patient work of a river carving something like the Grand Canyon, well, it wasn't just possible anymore. It was basically inevitable.
So once that incredible timescale was established, Hutton's idea became the absolute foundation of modern geology. And of course, it was eventually given a formal scientific name, a principle that lets us look at the world today and see the echoes of its deepest, oldest history.
So what's it called? Uniformitarianism. Yeah, I know it's a bit of a mouthful, but the idea behind it is actually beautifully simple. All it really means is that the physical laws and the geologic processes that we see happening today, things like erosion, volcanoes erupting, sediment settling, they've been working in the exact same way throughout all of Earth's long, long history. Basically, the rules of the game have not changed.
And this gives us this really powerful two-step method for reading the past. It's pretty cool. Step 1, you observe a process happening right now. So, for example, you go to a beach and you watch the waves crashing and pulling the sand away. Okay, easy enough. Step 2, you could be miles from any ocean and find this ancient, hardened piece of sandstone that has ripple marks in it. And you can infer that those marks were made by the very same wave action just millions of years ago. The present becomes the key that unlocks the past.
Okay, so how do scientists actually use this key? I mean, uniformitarianism isn't just some cool abstract idea. It's the fundamental tool in every single geologist's toolkit.
It's how they decipher Earth's incredibly complex story.
And this is where the principle really shows its power. By assuming the rules of geology have always been the same, scientists can look at layers of rock and figure out the sequence of events that happened. This lets them do something called relative age dating, which is just a fancy way of saying they know a lower layer of rock has to be older than the one sitting on top of it. And with a tool that's simple, they can start to piece together the entire history of our planet.
Let's try a little thought experiment, just to see how this works. I want you to imagine you could travel back in time, say 100 million years ago, and you're standing on an ancient beach. Based on what you know about beaches today, what would you expect to see? What would you hear?
You'd probably imagine waves crashing on the shore, right? You'd imagine the feeling of wind and sand. And why can you picture that so clearly? Because you know the fundamental processes would be pretty much identical to a beach today. It's the principle of uniformitarianism that gives you the confidence to make that leap, to connect the world you know right now directly to the deep, deep past.
So the next time you're out and you see a river cutting into its bank, or you're at the coast watching the waves shape the shoreline, I want you to remember James Hutton and his truly radical idea. You're not just watching water and rock, you're actually watching the very same ancient process that built the world we live in. The Earth really is a history book. And now, thanks to this one big idea, you know how to read it. You have the key to its oldest and most incredible stories.